Hey Math 1, I'm coming back at you with a new video on factoring by grouping. You guys saw one on it last week, but today I'm going to add a few nuances that you guys did not see in the last video. So let's get to it. So if you recall factoring by grouping, you could do it using prime factorization. I gave you a quicker way at the tail end of the lesson. I'll do factor by grouping with prime factorization for this first example only. So you got 14x squared minus 7x for my first group here. Very simple. You just take 14 and make it 2 times 7. X times x. Negative 7x is negative 1 times 1 times 7 times x. And remember, what you do is then you take what they share as their GCF. So they share a 7, they share an x. We stop circling the 1s unless it's the only thing that they actually do share. So 7x is my GCF. My leftovers are 2x. Remember, we need a placeholder for both the 14x squared, that's where the 2x comes from, and a negative 1. That replaces the negative 7x. All right, nothing to it so far. For our second group, we've got negative 2 and a 2x and a positive 1. There's not much to do here. It's negative 1 times 2 times x. This one, I'll call it 1 times 1, so at least, we got 2 factors to work with. They only share a 1, so that's the one I'm going to circle. So the GCF is going to be positive 1. The leftovers become negative 2x, and there's just a positive 1 left over. Now there's a problem here. The leftovers, in order to do the reverse of the distributive property, have to be identical. They have to be identical. So something went wrong here. I mean, they're really close. This is positive 2x. This is negative 2x. This is negative 1. This is a positive 1. Technically, if I just extracted a negative from this part, and then what happens when you take a negative out of a positive 1? Well, that's kind of tricky, unless you look at it like this. 1 does equal 1 times 1, but it also equals negative 1 times negative 1. Now the GCF is negative 1. Now the leftovers are 2x minus 1. Now I can say the GCFs create a binomial of 7x minus 1 as the first group, and the 2x minus 1s become the second. So how do I know that I should have done a rewrite of that prime factorization? It's because this one was exactly negative of this one in both parts. But see, what you can do is you can say, hey, if this was a positive 1 and a negative 2x and a plus 1, I can just say to myself, oh, there's that one move where all I got to do is say, we need to take a negative out of here. Taking a negative out of a positive makes it negative, and then that negative comes out here. Let's try example 2. All right, the first thing I want to highlight with example 2 is that I see a better connection between 3a squared b and negative 18a squared d. They're not like terms. I'm not trying to combine them together, but I think if they're in the same group, it's going to be easier for me to visualize that, hey, they both have an a squared. Also, 3 goes into 18 6 times. I can do that math mentally right off the bat. Similarly, 4 and 24 seem to match out a lot better. And I can see that they both have a C. So I'm going to rewrite this first. 3ab squared minus 18a squared d plus 4cb minus 24cb. And instead of doing prime factorization, I'm going to say this. these two group together, I can instantly tell that the 3 goes into both 18 and 3. So my greatest common factor is going to be 3. A squared, that's going to be attached to my GCF. And now my leftovers are dividing both terms by 3a squared. So 3a squared divided by 3a squared cancels out, but we're still left with a b. Like I said, negative 18 divided by 3 is minus 6. A squareds cancel with a d left over. Do the same thing with the second group. They both share a 4. Now this is one of those situations where it's like, do I take a negative out right away? Do I know? Maybe you got to wait a little bit and just say it's a 4. I'm not sure if it's plus or minus at the moment. And they both have a c as well. So my GCF is either 4c or negative 4c. So if I just divide by a neutral 4c, that's kind of like dividing by positive 4c. 4c divided by 4c is positive b, which is exactly what we want to match up with this other one. So plus 4c. And then if you divide this part by 4c as well, you're going to get negative 24 divided by 4 is going to be negative 6. The c's cancel out, and then there's a d there. All right. Now the GCFs are going to create their binomial group. And then the b minus 6d is going to be the second binomial, and it's factored. So sometimes it's hard whether or not you can foresee whether or not it's negative or positive, but with just a little bit of investigations, you'll see it soon enough. This one showed you guys that you can kind of, you can reverse them, but you technically didn't have to reverse them. Number 3. All right, so I think right off the bat you guys are noticing, yeah, these two should definitely go together. 30 and 90, 30, 60, 90. 5 and 15, 5, 10, 15. It's pretty obvious that the first two should be grouped together, so we're not gonna rearrange. So 30 goes into 90 3 times. So they share 30. Okay. They also share a b. One's b squared, one's b. So that's my GCF. The leftovers are going to be whatever you obtain by dividing by the GCF. So if I divide that by 30b, I'm going to get 1b. Take this divided by 30b. The b's canceled, and you're left with positive 3. Over here, it's clear we got to take out the negative in order to create a positive b plus 3 in its leftovers. So I'm going to take out the negative 5 right away for my GCF. And that's what we're looking for. It should be b plus 3. So this is kind of a formality. It's like once you find the right GCF, it's like negative 5 divided by negative 5 is 1 with a b. Oh, it's supposed to be b plus 3. Yeah. The GCFs come together to create this factor. And then the b plus 3's make up the second factor. All right. It's not done yet. I put a little asterisk there to say, further investigation is needed. Here's why. 30b minus 5. If somebody from, okay, so if I put this on a previous assignment from like last week or whenever we last talked about this, and I said, factor that polynomial by just taking the GCF out, you guys should have something to say. You'd say, hey, 30 divides 5, 5 divides 5. I can say that the GCF here is 5. Which means The leftovers are going to be divide by 5, 6b minus 1. What this is illustrating is that you have to take the 30b minus 5 and factor it one step further when you recognize that it's not completely factored. So this becomes 5 times 6b minus 1, just this factor, and then you bring down the b plus 3 unchanged. Because b plus 3 was completely factored. All right. So there, that's kind of tricky. Sometimes you can see right off the bat that they all divide 5, and you can take that 5 out at the very beginning. All right, last example. All right, there's a lot of variables going on here. I'm just going to try this by grouping the first two together, because they seem to be sharing quite a bit. They both share an a squared, b squared. So if I took the a squared, b squared out right away and divided both parts by it, they cancel and you're left with 3 plus 16. That looks pretty awkward. Let's keep investigating. If you group these two together, they're both even, so it looks like they share 2. And then the minuses, you'd want to take that out because you're left with just positives over here. But this is not going to do it, because if you divide the negative 2 out, this is a to the 4, b to the 4. Those don't share anything else. You're left with 4a to the 4 plus 3b to the 4. All right, this is a big problem because these leftovers are supposed to be identical factors. If they're not identical factors, that means that they needed to be regrouped. It's not an option. You have to do it. So what I'm thinking right off the bat is that 16, 8 for these constants, a squared and a to the 4, they are going to share something. So let's group these together. And then these two go together as well. It's hard to tell right off the bat who's supposed to go first to make this right. So plus minus, maybe we'll just keep it as plus a squared b squared minus 6b to the 4th. If we got to change things later, we'll do it when it comes up. So 16 and 8, they share an 8. Okay, so divide by 8, that's going to be a part of the greatest common factor. They both have at least a squared. And that's all they share. So this is the greatest common factor. The leftovers are what is obtained when you divide by the greatest common factor. So 16 divided by 8 is 2. The a squared's canceled, and you have a b squared left over. Negative 8 divided by 8 is negative 1. I'll just leave it as negative. A to the 4 over a squared is a squared. So, we got this so far. We're almost home. Group these two together. They clearly share a 3. So, I'll put a plus 3 for now. And a b squared. At least a b squared and b to the 4. So here's my GCF. The leftovers are obtained when you divide out. So the 3's cancel. The b squareds cancel. You get a squared. 6 divided by 3 is 2. There's a minus in between them. And then b to the 4 over b squared is b squared. All right, this looks pretty good. Except these are exactly opposites. So here's what you do. You say, I'm going to take out a negative from here, which makes the 3b squared negative. It makes the a squared negative. It makes the 2b squared positive. So now this is technically 2b squared minus 2a squared, which looks just like that. So the GCFs come together like this. And you can pick either one of these. I think this is the probably better one to look at. And you're done. Hopefully that was helpful. Good luck.